Go for it. There it is. Okay, hi folks. Welcome to the May 2022 Northwest C++ Users Group meeting. I'm actually presenting tonight, but I wanted to do one little announcement beforehand. The August meeting will be a group or a collection of lightning rounds. So anybody who has a talk they would like to do that's fairly short, we'll probably do 5 to 20 minutes, depending on how many people we get. Feel free to just show up and do your talk. August is 1 month before CPPCon. So if you're going to do a lightning round at CPPCon or something like that, the August meeting is actually a really good time to practice. So with that, I will go ahead and jump into the presentation. Let me do one thing. I'm going to turn my camera off before I do that. Okay. Okay, can you folks see that okay?
I just see LC.
No presentation yet.
Hang on. I know what I'm doing wrong. Forgot to share the screen.
Yeah.
About now.
Yes.
There we go.
That guy off. Okay. So tonight's talk isn't actually about C++ stuff, although it's kind of related. I'm going to do a talk on some Rust, which is another programming language if you haven't run across it yet. I'm not going to get into actually kind of like an introduction to Rust, because you could always go read the book and look up that. I'm going to more focus on kind of my experience with Rust, programming with it over the last year or so. Whoops. So we'll look at a collection of topics that I found interesting. In some cases, I'll compare and contrast those to C++, and in others, we'll just look at the Rust topic. So the first one's the development environment. Rust is very complete right out of the box. The list of various tools I've got here all come standard. So Rust Up is a toolchain management program, which also includes download and management for cross-compilation tools. So you can basically say Rust Up, give it the trigraph, ARM, x86, whatever, codes, and it will pull down the right compiler and cross-compile for you right on your desktop. Cargo is a build process management tool and package management. We'll talk a little bit more about that in a bit. Rust format is a formatter, and you run that with cargo format. Very much like plain format, for instance. Clippy is the linter. You run that with cargo Clippy. And it's actually a very good linter. I'll also note the linter in this case puts up not just actual bugs or defects, but actual hints as to how you can write your code better in a lot of cases. We'll talk a little bit more about that in a minute. Documents, the documentation generator is built in. There's a syntax for putting up documenting your code in line, kind of like deoxygen or doxygen, depending on how you say it. But that's actually built right in to Rust. It's not an add-on. There's a unit test framework built in. You run with Cargo Test. There's a performance testing framework that you run with Cargo Bench. The other one that's fairly interesting is Rust has a language server. And I think some of the other languages are starting to do this, namely Python. The language server is a plugin for your editor. And you can see there's a whole list of editors supported. And the quality varies a little bit between the two, or between the editors. But it will actually give you syntax highlighting, error checking, and suggestions right in line as you're typing. The best support that I've seen is actually in Visual Studio Code. That seems to be the best, has the best support for the language server. I personally use Sublime, and it's quite good. I've worked with a couple people that use Atom, which I now see I've got in there twice. Sorry about that. I'll fix that. And yeah, that one's pretty good as well. Haven't seen. I know a couple people use Vim, but I've not seen them use the language server plugin with Vim. Okay, the development cycle is also very, very different in C++. You still have the same edit, compile, run, basic mechanics of any compiled language. But the way this works with the language server and the online or the inline comments, it gives you a much different feel. You feel like you're having a dialogue with the compiler every time you save, edit, and build. It'll pop up and you'll save your file, and it'll pop up with a set of hints, some of which are just syntax errors and stuff like you would expect. Some of them are, you could do this piece of, or you could write this piece of code better if you use this thing. And usually this thing is a new feature in the language. And so it kind of teaches you as you go, and you're having more of a back and forth with the compiler than you normally do with, like, say, a straight C++ compiler. Kind of hard to describe exactly, but when you experience it, you pretty rapidly recognize you're doing something a little bit beyond what you're used to with just a straight compiler. The suggestions will also include various snippets. It'll recognize fairly complex coding constructs and say, hey, this could be done more simply this way. To that end, the coding style is idiom-based. So if folks are familiar with design patterns, the idiom paradigm is like little mini design patterns. They are, 3 to 5 lines of code, typically, sometimes just even 1 line of code if it's still fairly complex. And it's a way to solve a very simple problem, like iterate over a collection, or read, open a file, read its contents by line. And you can go on and you can find many, many examples of how to do these, these simple little coding constructs. It's much more important in Rust than I've found in other languages. The idioms are actually built into the linter, and it will suggest that you follow them. Sometimes the linter will actually enforce the idiomatic pattern. I've seen that as well. And I haven't turned it off, but I suspect you can change that with the linter settings if you really wanted to. Although I just kind of take that as a out of the box setting. The Rust language is evolving very, very rapidly. So one thing to be aware of, unlike, for instance, C++, where there's an ISO standards body and a formal language specification and so forth, there is no formal language specification. In the Rust world at the moment, the compiler is considered the specification. This is kind of interesting. One of the things that really gets you is that places limits on actually where you can use Rust. So currently I'm working in the aerospace world. We do use Rust, but aerospace tends to be governed by DO 178X ABC. There's a whole bunch of these different standards. And you cannot use Rust for the actual project code, for instance. So like the code that would go on the vehicle, or the code that would fly the airplane, or something like that. Because you don't have a language specification, you cannot actually fully qualify your tool chain, because to do that you have to match your tool chain up to the specification. And that actually limits where you can use Rust. all of the tooling that goes around it, the testing frameworks and stuff like that, that's actually fair game for Rust, and that tends to be where we're using it. But you do need to be aware of if you're going to go into a formal qualification, Rust isn't there yet. Now they are building a second Rust compiler. The current Rust compiler is built on top of LLVM, the LLVM toolchain, I should say. And they are working on a GCC compliant toolchain. I'm going to bet in that process they're going to have to build a specification out of that, because now you're going to have two compilers, and you're going to have a specification for it. Something else that this does allow for, though, is much faster language development and iteration. So Rust has what they call additions. These are essentially language breaking changes. So unlike C++, Rust will break backward compatibility. However, they only do so every 3 years. And when you build your code, you can say which edition you want. The current edition is 2021. The prior edition was 2018. You can actually specify that in your the build manifest. So there's a way to get around it. The other thing is Rust has two compilers, a stable and a nightly compiler, pretty much just what they sound like. The stable is what's considered stable. The nightly is released every night and has more features. The difference is the stable compiler is updated every 6 weeks. So basically, every 6 weeks, you have the option of stepping your tool chain forward and picking up new features, enhancements, bug fixes, whatever. Much different than the C world. The language is also what I'd call less regular than C++. It's not quite as developed, and there's more, the edge is a little more ragged. The way you do things in some cases is not quite the way you would expect, and it's just, it's a function of a younger language, essentially. Yeah, let's see. Okay, the next one is crates.io. So kind of like Python, Rust actually has a very robust ecosystem for packages and add-ons. The packages are called crates in Rust, and the registry is integrated with Cargo, which is the package manager, for both download and version management. Rust actually seems to have gotten version management correct. You can actually specify the full version to use at any point in time, and it'll lock that version in, or you can say, I want this to progress and stay up to date. There's a rather blurry line between the standard library and what ends up in the registry, at least in my mind. There is a standard library, and there are these, the package registry with crates, at crates.io. But some of the things that you would expect to be in the standard library are actually in crates.io. We'll look at one in a moment, the random number package, for instance. It's actually a crate, not part of the standard library. Most of the packages in the registry have an MIT or Apache style license. I don't think I've seen anything that didn't, at least have an open license like that, but you should be, if you're building something commercial, be aware of it and keep track of your licenses. The packages also pull in other packages quite generously. And I think that's what drives the MIT or Apache style licensing, is because it's a lot more like Python, where you just go in and you pull everything down. The repository of the registry is not really curated anyway. So watch your documentation quality. Look at the number of recent downloads. Some crates are de facto standards. There's one called SERDI for serialization and deserialization, and RAND, for instance, the random number generator. Those are just kind of de facto standards. But there's some competition ones out there. The last release and the release cadence is also something to look at. So you do have to be a little bit of a cautious consumer. But at the same time, there's pretty much, whatever you want out there. This is the website for crates.io. This is actually something I find fairly unique to Rust. I don't think I've run across anything else that has a website quite like this. Basically, you just go to crates.io, type in what you want, and they'll give you a list of all the packages that meet your keyword. Python has some of this, but it's not quite as straightforward as this. If you want to publish, the repository or the registry, I should say, is open to everyone. So you just build your package a certain way, and then you can upload it. Once you upload to this, it's kept there permanently. So there is a couple of mechanisms where if you want to deprecate or remove something, you can do it. But the general idea is once somebody pushes to the registry, it stays there. So you don't have to worry about things disappearing. Notice as I captured this, 73,000 crates in stock and 11 billion downloads. That's a little misleading because Rust downloads pretty frequently. For instance, our CI system at work downloads every time you do a CI build. So it's a little exaggerated. Let's just take a look at a typical package entry. We'll look at the RAND. So it's the random number generator. Folks see my mouse okay? Basically up here you'll get the name of the package, the current version number, and this is semantic versioning. There's documentation, top-level documentation, metadata, so when was the package updated, what's the license, the size, and then there's this install. Essentially, there's a file called cargo.toml, and when you pull in a dependency, you put a line like this into your cargo.toml file, and that tells your build environment to use this particular package. It automatically assumes crates.io, and it'll pull the package with that package name and that version number, or better. So this will take 0.8, 0.8.5, 0.8.4, 0.8.6, but it will not go to 0.9 unless you tell it to. You can also lock down the specific version. There's a home page and the formal documentation, and of course the repository. So that's just kind of an idea of what you get for a typical package entry, and these are all standardized. Let's see, any questions so far? Okay. So oh, go ahead.
Just in case, I'd like to mention that for Visual Studio Code, there is an extension named Rust-Analyzer, which helps a lot when typing the text.
Yep. Yeah, and that's actually, it ties into that language server I was talking about earlier. So yeah, for each editor, you have to go look up and see what the package is to extend and connect to the language server.
I had one question, and that is, how do you avoid supply chain attacks on the crates? So somebody could, for instance, introduce a malicious bug into a package which could end up in your code?
So far as I know, that's not protected against. So as far as I know, it's never happened, but it is a vulnerability. There's nobody monitoring the repository. So you need to basically keep track of, what you're pulling in, and you can actually pull the crates if you're doing something that's critical like that. You can actually pull the crates down and build your own little repository out of them as well. So yeah, that's a good point. That's another weakness of the current system.
Another question.
Yep, go for it.
Whatever is uploaded to that crates.io, is that available in binary form or in source form? Source
It's
code?
actually, it's always that I've seen source form. So that's the other
So
thing. These are all
it's
source
possible.
code. Yep,
It's possible to take a look at the code and make sure that it's fine.
that's correct.
Okay.
So you can do that. Fundamentally, I think, I'm not 100% sure of this, but I think behind the scenes, crates.io is actually a Git repository. I'm not 100% sure of that, but it kind of acts like it, and I've seen some things that tell me that's kind of the case. If you have a Git repository that's like your own local code and local libraries, you could actually set that as a dependency as well, and you treat the crate exactly the same way, pulling it from a Git repository as from crates.io, and even just a local file path. So you just the specification is different. Crates.io is assumed, but you can specify a Git repository or a local file path with, slightly different syntax, and conceptually it's the same thing. So two of the crates that really always drive me nuts, and this is actually one of the problems with not having this, fully curated. There's standard time duration and chrono duration. So just like C++, std : is the standard library. Both of these have a duration object in them. They're kind of similar, but they're not compatible. So at the top, you'll see Lloyd's rule. If there's two similar things, Lloyd has a 90% chance of finding the wrong one. I get these mixed up all the time, and it's something that, if you're just starting out, drives you a little bit crazy. The chrono package is a bit more feature-rich, and it seems to be usually what you want. But that's just kind of one of the little notes I found as I went through this. Okay, let's talk about the borrow checker. So this is probably the most loved and the most hated feature of Rust. The borrow checker is a key component of the language. And what it does is it enforces compile time checks on, I've got variables in the deck, but fundamentally any memory object or any object. Various checks of the handles: initialized before use, not moved twice, not moved while borrowed, and cannot be modified by more than one owner at a time. And there's a few more. Fundamentally, the way this does, the borrow checker works, is it implements a concept of ownership. So ownership is something that, a lot of people use in, C++ and other languages, where you've got a piece of code or a routine or a module that owns some resource, a piece of memory, for instance. Rust actually puts this borrow checker into the compiler and enforces rules on what you can do with that code or what you can do with that object. The most prevalent one is you can have any number of read references to the object at a given instant. You can only have one, well, or I should say it this way. Once you establish a write or a mutable reference to an object, that's it. Until you release that mutable reference, that's all you get. So you get fundamentally one owner at a time for modification. That essentially eliminates race conditions. And when you combine that with lifetimes, it also means you don't have memory leaks, you don't have use after free. It also makes sure the object is initialized before it's used. You cannot move it twice. You can't move it out from under something that's borrowed. So if you have any type of reference to an object and then you actually invoke something that would carry out what we call move semantics, that will not be allowed. It's essentially these guarantees that make Rust unique. The downside is it's going to force you to use better and different patterns when you're writing. When you first start using Rust, you're going to rip your hair out because you're going to say, I've been doing this for 30 years. It's my pattern. And Rust says, no, I'm not even going to take that. And fundamentally, you're violating one of these borrow checker rules, typically, is what's going on. So this is actually an example of the, the mistake, I guess I should say, that really convinced me Rust is unique. So if you go on to Compiler Explorer does have a Rust compiler available. And when I was first playing with Rust, we were just, hacking around and, just looking to see what the, what can we do? How does it behave? How does it feel? And I made a very common mistake. If you look at the left-hand side, this is basically a, for statement. So for element in a list. So I've created a list, go up here. I've created a list and I've added 3 elements to it, 0, 1, 2. Now I'm going to iterate over that list. And if the element is equal to 1, I'm going to pop it off. So this is essentially modifying the list. Okay? I'm modifying the list while I'm iterating over it. If I try to compile this, you'll notice a second mutable borrow occurs here. First mutable borrow occurs here. So this is a compiler error, and this is how it'll typically show up. Exactly how it shows up depends on your plugin. But you can see it's not letting me mutate or modify the list while I'm iterating over it. And it can do that. At first I'm kind of like, whoa, this is magic. And no, when I really understood what the borrow checker was doing, I've taken a mutable borrow here, and then list also wants one. So there's a second mutable borrow, and the borrow checker says, you can only have one mutable borrow at a time. And that's all it needs to stop this. The interesting thing is this happens at compile time. This level of detail in checking incurs no runtime overhead. It's all done at compile time. Now, there is a way you can actually defer this into runtime, and that's a design pattern called interior mutability, is what they call it in the Rust world. So there's cases where doing it compile time, it's just not sufficient. You can't know enough at compile time to say, this is okay or this is not okay. And in some cases, you cannot reorganize your code to make it, reasonably work with a compile time only check. So there is another paradigm you can go into and use it. It's a little more complicated, but the default is you get this compile time and it just works. Okay, another one that I was really interested in, and this is kind of historical, is the efficiency of the switch statement. So Rust has the match statement. It's very much like a C++ switch statement, but it includes much more advanced pattern matching. So a lot of the code I do tends to be performant, or in performance environments, and performance is important. So I was really curious, as fancy as this match statement can get, and for instance, you can just match strings and return codes and all kinds of stuff in the match statement. How efficient is it really for just a simple case? So I wanted to look at that. Also note, Rust currently uses the LLVM backend compiler, and the optimizations you're going to see are from that backend. So these are the downstream optimizations. Of another quick note, Herb Sutter has proposed a construct for C++ that's very similar to this, and that was at the last. That was announced at the last CPPCon. So his talk is there. So something like this may also be coming to C++ in the future. So essentially what I did, back into Compiler Explorer, and just a little piece of test code, just a quick note. This is a public function called test code, and it returns a 64-bit integer. That's what that line means. Let, you have to assign your variable when you initialize it. So this is declaring the variable, initializing it. All variables by default are immutable unless you say mute. That's another big change from C++. And for. So it also does type inference. So I don't have to declare the type here. For is, it knows it's an int64, and if it doesn't, it'll actually trace back to the return code, walk back up the chain, and then figure out what these things need to be. Actually, in this code, it could be different. And then match is it's like a switch, so it's match value, and then these are essentially the case statements: 0, 1, 2, and then I'm just returning a different value. The underscore is the default. So this is one I just happened to try. And if you look at the generated code, so if let's just go through real quick. The value's 4 is not in the list, it's going to return 0. And this is essentially static. If you look at the compiler generated XOR EAX, which is a zeroing of the register, and then it just returns it. It said, well, I've got essentially a constant expression here. It's going to be this, and it reduced it to a constant expression. So I thought that was kind of cute. It wasn't really what I was looking for, though. It was a little too simple. So now I went in and basically the same function, but for matching the value, I go 0, 1, 2, 3, 4, and I'm just printing the text around it. So print line is equivalent to, well, it's the print statement, like cout in printf in C. And now you can take a look at the code that's generated here. Essentially, let's see. So it starts off with a range check, comparing it to 4. It'll jump down here if not. And then this block of code right in here is essentially an indirect jump based on the value. So this did what I was expecting. It didn't create an if cascade. It did a computed jump. So it's essentially O of 1 time, not O of n time. And this is kind of what I look for in a, to see if a switch statement's efficient. Other alternative. See what this one do. There's another case I thought was actually interesting. I reduced the list to just 0 to 2. And you'll notice in this case, I actually did get an if cascade. So it's comparing it to 1, jump, compare it to 2, jump, and then just a jump. So apparently in this particular case, it decided this is more efficient. And again, I'm pretty sure this is actually the LLVM backend converting this into a, optimizing it for the specific processor. I was pretty happy with that. In general, Rust can be just as efficient as C++, or I'll even, go one step further, can be just as efficient as C. The compile time checks take place at compile time. And if that saves you having to put checks into your actual code, then Rust can actually be more efficient because there's a way to pull those checks essentially out of the runtime. You do pay for this. One of the complaints about Rust is the build time is fairly long, and it can be. In practice, I found this is actually no worse than C++ with a linter such as clang tidy. So in general, if you're going to compile, if you can compare Rust and C++ compile times, Rust does take longer, but if you're going to do Rust with a linter, or excuse me, C++ with a linter, then you're back on the same order as Rust. So if you're doing about the same thing, it's about the same amount of time. The other thing I would note, because of the borrow checker, constructing code which does not copy values is definitely more difficult in Rust than in C++. So the borrow checker restricts you. One of the trades you can make, so you've got a couple of trades when you get into this, or trade-offs, I should say. You can basically just copy the object. And sometimes that's not too bad. Sometimes you actually want to do that. And the performance isn't that bad, especially if you're not working in an area that's still performant code. If you're initializing, it's often easier to just copy values around. You can actually go in and write more complex Rust code to manage the references more directly and get around the borrow checker that way. So that's another option you've got. Or you could actually go to unsafe code, in which case you can do anything you want. But in my mind, if you're going to do unsafe code in Rust, just go use a language designed to be unsafe, like C++ or C. You'll get the linters and stuff are actually going to be much better in that case. So far as I know, and I could be wrong on this, Rust does not have any linting capability in their unsafe code. It just turns off all the checks, and now you're kind of on your own. The other thing that trips me up a lot is Rust really doesn't have any inheritance. They promote a composition pattern over inheritance. And in practice, I found this results in one of the following. You have to duplicate code in each object that you would normally just put in a base class. Sometimes you can get around that with using a different object model. You can also use generic functions. And you can also generate a family of objects with macros. What I've found in Rust is the latter two, the use of generic functions and macros, tends to be the way most people address this. And it's a little bit, again, it's a little bit harder to code, but it turns out being, more efficient and sometimes actually fewer lines of code, even though it's more difficult to write those lines of code. Brings us to the topic of Rust macros. There are two macro systems in Rust, and these are not like anything in C or C++ land. In C and C++, a macro is fundamentally a text substitution. In Rust, there's the macro system called macro rules. The substitution happens in the abstract syntax tree during compilation. So what that means is when you put a parameter in your macro, you can restrict it to being a specific syntax element, an expression, a block, a constant, a literal, so forth. So you can say only this type of syntax element can go here. And that actually eliminates, as far as I can tell, all of the ambiguity that can crop up with the macro substitution in C and C++. You can actually take this and build domain-specific languages in Rust. I've done that intermix with normal Rust code. It's fairly straightforward to do. It's got a bit of a learning curve on it. And you can do that in the macro rules. There's a second, go down to this one. I've jumped ahead a little bit. So macro rules is the one I've been talking about. The other type of macro is a procedural macro. The procedural macro in Rust essentially takes a stream of tokens and emits a stream of tokens. You can do whatever you want with this. You've got full access to, you've basically got full access to the abstract syntax tree. So you can take any abstract syntax tree and convert it into another abstract syntax tree, putting in your own tokens, your own words, your own whatever you would like to do. I have not played with this yet, but from what I've seen, it can be very, very powerful. Okay, that's kind of the bulk of it. If you're interested in getting into this a little bit more, I've got the Rust homepage listed here. And then there's another page which is really interesting. It's called the Little Book of Rust Books. One thing about Rust is there's the documentation for it is a little more, not quite as developed as it is in C++ land. So it's a lot more open source and community generated. The Little Book of Rust Books has a collection of these. There's official books, of which the first one is called the Rust Programming Language. You should start there. And then there's books for cargo and unsafe code and all the other features. I've also listed a cheat sheet I found helpful in the past. And with that, we'll see if there's any questions. I'll stop sharing and go back to the camera. Okay.
Lloyd,
Yeah.
isn't the macro system seems a lot like C++ expression templates, where you can create your own DSLs with it and things like that? I was
Yeah,
curious of your opinion on that.
Yeah, I have not played with in some of that. Well, I haven't played with the expression templates in C++ too much. Let's put it that way. But I think your statement's fair.
All right.
It's I've created my own domain-specific language with it. Fundamentally, what you're doing when you create a DSL, or the way I did it, was I was using the DSL to remove boilerplate code. So I had a whole selection or a whole set of routines that were somewhat similar and had a lot of common setup code in them. And I reduced that into a language and then just used that to select and fill in boilerplate code and mix it together.
Okay.
Right.
I'm also curious about your when you talked about the runtime overhead, because I just got through reading an article or a presentation by NVIDIA, which shows Ada Spark over Rust, and one of their criterias was Ada had a lot less runtime overhead with the checks in it. So I thought, well, that's fascinating, because I didn't think Spark had any runtime checks in it, and I had the impression, from looking at Rust, the same as you do, that Rust does not have a lot of runtime overhead.
Yeah. So I think let me start with this. I have not done a ton of taking Rust code and putting it through Compiler Explorer and looking at the assembly code coming out. I've done some of that, but not a lot. From a performance standpoint, I have done a reasonable amount of looking at its performance, and it performs pretty much what I'm used to seeing with C or C++. So
Okay.
I think this actually could depend a lot on how you write your Rust code. One thing that could really be tripping them up is, and this trips me up a fair amount actually, the borrow checker tends to not require, but the easy way to get around the borrow checker is to make a copy of your object.
Mm-hmm.
And if you're new to Rust and your coding style is to take the easy way and make a copy of your object, I could very easily see that getting misconstrued as runtime overhead, because it's easy to do. The borrow checker actually kind of encourages you to do it. And if you're new to Rust and not realizing what it's doing under the covers in some cases, that will definitely give you a performance hit.
Oh, I didn't realize that. Yeah, that makes a lot of sense.
Yeah, so I haven't obviously read the article you were looking at, but it wouldn't surprise me if they're kind of in that trap.
All I got to do is Google NVIDIA Ada Spark.
Okay, take a look at that.
It's like the top hits on it. Unfortunately, it's a video, so you have to sit through it to get the information.
Yeah. Yeah, so that's interesting. And I haven't done Ada programming ever.
Neither have I. I remember when the Ada spec first came out in like 1980, I got a copy of the mil spec on it and I read it and I decided the language was unimplementable.
So
Well,
being in the aerospace world these days, I've worked with a fair number of people who have written stuff in Ada, because the old style aerospace was a lot of stuff was done in Ada. But it's really not anymore. It's all C++ now, or C.
What, really? Why is C++ supplanted Ada?
I don't know. I find it rather interesting, but pretty much every place I've worked in the aerospace world, which has only been for like the last 4 or 5 years, something like that, everybody's used C++ for the time critical code. And the non-time critical code, they've been tending to use Python, but now use, for all the tooling and stuff around, Rust is becoming a lot more popular, specifically because of its guarantees.
Uh-huh.
So yeah, it's perplexing. They also tend to use Linux quite a bit. That's also common knowledge. SpaceX is known for, we've got, I can't remember, it's 10 or 20 Linux machines on their rocket. And I'm just like, really, people? It works. And at least as far as I can tell, it's for the ease of development. If you get into Ada or some of the traditional aerospace paradigms, the development cycle, it can get very, very heavy.
Okay, I didn't know that.
Yeah, it was actually kind of an eye-opener to me when I got into it. Okay, other thoughts, comments, questions? Okay.
Having your
Tom.
having your experience so far, which language would you recommend, Rust or C++, and for which projects?
So I'm going to pick on the last one first. For which projects is really the key. Both of them are applicable for certain types of projects. There are scenarios where one has a very definite advantage over the other. So one I mentioned in the talk is any place where you're going to have to formally qualify the final program. So if you have to go up against a DO 178 style specification, for instance, you cannot use Rust. Rust has no formal language specification, and that limits how far you can go through the qualification chain. So fundamentally, anything that's going to be human rated, for instance, Rust is off the table for that code directly. And I'd have to go through what they call the design assurance levels or the DO 178 levels to see exactly where that cutoff comes in. As you go further down the chain to the less and less rigorous code, you don't have to do as deep of a qualification. So you could use Rust there. The other one I found where Rust is not really a good choice is GUI code. So if you're going to do something with a rich GUI, for instance, Rust is probably not your best choice. It doesn't have a good GUI framework yet. There's some out there, but they're not as robust as, say, MFC or Qt, for instance. Places where I do see Rust used a lot are, well, in the case I've got, say you've got a small development team and you want very high assurance that your code is correct. So correctness is the primary thing you're looking at. That's very definitely a Rust domain. You will take more time to develop it, and Off the top of my head, once you're seasoned in both, it probably takes me maybe still 1.5 times to write something in Rust compared to the speed I could write it in C++. And keep in mind, I've been using C++ a lot longer, so there's some experience in there as well. The debugging time, however, for Rust, once you get it working and running, you basically don't have to worry about race conditions, memory leaks, all the various use after free or pointer and reference issues. They're just, it's assuming you stick to Rust and not go into the unsafe realm. All those are basically gone. So you end up writing fewer unit tests. You write, you have to spend less time debugging. So I call it auxiliary tooling in aerospace, for instance. It's not the main system that's going to fly, for instance, but it's all the tooling that checks the main system that's going to fly and things like that. Rust is a very good choice for that. They tend to be command line driven. I also see it used a lot in financial world, where you've got high dollar values and transactions at stake. Again, you've got guarantees that you're not just going to drop some object off into space and lose $1,000 with it, somebody's money, that type of stuff. So I've got a little personal project that stock stuff that I was kind of learning Rust with before, and that actually works really well because you get a certain level of assurance basically for free, and in the case where you don't have somebody else to really go in and do a code review for you, Rust has a benefit there. Essentially, the benefit, that's another point I should make. One of the benefits of using Rust, and this is, I've seen this in a couple of my other talks around project development and so forth. Keeping the tools, well, let me phrase it this way. Automating as much of the code checks or the code review as possible is something I consider desirable. So, syntax checking and your style checking and your linting, push all that into your automation. Rust takes that one step further. So that when you're doing a code review on a Rust project, you can spend much more time looking at the algorithm and the implementation of the algorithm and not having to worry as much about the, the details of, hey, did I, cover this weak spot of the language properly and handle this error condition properly and things like that. Actually, that's another, well, C++ has it now too, where you must use a return value. Rust has that same type of thing. So, it's, you get a lot of that just built in automatically.
All right.
Yep.
Are there any aspects of Rust that you would like borrowed or taken into C++?
The match statement is one of them for sure. The match statement turns out to be very, very powerful. It's almost like a Python. Well, Python doesn't really have a switch statement, as I remember. So I'm trying to think of a better example. It's a full pattern matcher, essentially. So it can match against strings, it can match against whatever, and just deal with it. So I like that. As much as I hate to say it, I wouldn't actually mind if the borrow checker got sucked into C++ land, but I can guarantee it won't be. It's just far too limiting, and it breaks far too many coding paradigms that are common in that land. So, but I do like, as much as I want to rip my hair out on a regular basis because the borrow checker is not letting me do what I want to do. I fully recognize that what I want to do is not the best way to do it, and the borrow checker is protecting me from myself. That's why I made the comment. It's the most loved and most hated feature. A lot of people say that. They recognize its value and they want to kill it.
I could imagine some opt-in attributes to C++.
Yeah, I think you could
adorn
possibly
pointers
do
with.
it that way. The flip side too is if you're really going to do C++ work and want some of the same assurances, You can get about 80% of the way there with a good static analysis checker. Clang Tidy is one that I typically use on C++ now. And it catches a lot of the same things, but not all.
Well, it's entirely possible to add a borrow checker in a C++ because I added one in the D.
Oh, you did?
I think I gave a presentation for it at NWCPP at one point.
I don't remember that.
I remember that.
Are you sure it was us? Because if it
I gave
wasn't, I
it
would
multiple
love
times, and I'm not exactly sure who all I gave it to, but yeah. And it's opt-in, of course.
Yeah. Actually, if you haven't given, let's check that, because if you haven't given that to C++, this group yet, I would love to have that one, especially coming on the tail end of Rust.
Well, if you've checking I haven't, and you got an opening somewhere, I'll give it again. You know,
Okay, I'll check for that. Yeah, because
it's actually not that hard to do. I was surprised.
yeah, that's one of the things I'm finding interesting. I haven't looked at the borrow checker from the compiler's point of view. I've only used it from the developer or the coder's point of view. Conceptually, it seems simple, but it also leads me to think there could be a lot of caveats behind it. But that would be really interesting because one of the fascinations I'm finding with Rust is when I go to use paradigms that I've used in C and C++ forever, and I'm not doing anything exotic. I'm generally doing stuff the way everybody else has done it in C and C++ for years. And the borrow checker comes back and says, no, you cannot do that. Like, oh, I wonder how many places I screwed that up in the last 30 years.
Oh yeah. I've had an awful lot of trouble unlearning old paradigms and learning, even though I understand the new ones, I find myself writing the old patterns all the time. And it's really tough to, graduate from that.
Yeah, it is. And one of the things I've heard about the deprogramming language is I've heard several people mention they'll hire people that know D, even for a C++ job, because knowing D makes you a better C++ programmer. I've heard that several times.
Wow.
I think the same is true of Rust. Even if you don't use Rust, knowing it and knowing how it thinks with the borrow checker and some of the other aspects forces you into programming patterns. They're just better overall.
I agree. I agree totally. The interesting thing about memory corruption bugs is back in the 80s, I was writing in C a lot. I had memory corruption bugs in my code all the time.
Oh, yeah.
All the time. And,
Yes.
the failures would be crashing, wiping my disk drive. I hated them. And over 10 years, I found that my code had fewer and fewer memory corruption bugs in it. It's not that the compilers or the languages got any better. It's just that I sort of developed habits to avoid it.
Yep.
And it's to the point where I haven't had a memory corruption bug in several years now, which is amazing considered I would do it all the time before. But, a lot of people and companies can't afford to wait 20 years for their programmers to stop making memory corruption bugs. You need a better solution than that. But it is interesting. These things don't do me any good. And another interesting thing was D's added a lot of checks for memory corruption problems to it.
Yeah.
And there's a thread on the news group where these people are saying, I added all these memory protection things and they didn't find a single bug in my program, so it's no good, of no value. And I countered and I said, but you're talking about adding it to a program that's already been debugged.
Yep.
So of course you're not going to find problems with it.
Yeah. No, and I've run into the same thing. You make one stupid little error that takes 5 seconds to create, and you'll spend the next day or two or more chasing it down and getting it out of there. If you even find it in the first place.
Right.
And it's, I'll debate this with program managers and stuff sometimes, but I'm I'm much more a fan of spending more time up front to ensure the code was done correctly than get the thing done quickly and out the door and fix it later.
Mhm.
And it kind of depends on which industry you're in, how well that gets accepted. Aerospace, I get no arguments on that. Some industries like game development, they're just get it out the door. If it crashes once in a while, we're not going to be too worried about that. We'll fix it later. We can always update it.
A few years ago, one of the PC or the C linter programmer developers offered me a free copy to try it out on my code base and see what I found out. And this was back when the decompiler was still written in C++. I hadn't converted it over to D yet. So I thought, oh, great, I'm going to run on there and find all these bugs. I found 1,000 false positives and not a single bug. And I thought about that, and then I realized again, it's old code. It's all been thoroughly debugged. It's not going to find anything.
Yeah.
Those linters and all that are for new code, not for old code.
Yep. Yeah, you typically do run linters on, any type of flight code or something like that. That's pretty much standard. And they find real stuff pretty regularly.
They do?
Yeah.
I'm surprised.
It's, you're writing very specialized code with at the moment usually fairly small teams, and it's all fresh. You're writing everything from the ground up.
I could see the point of the false positives it had. They're mainly stylistic issues and all that stuff, but they weren't actually bugs.
Okay. Yeah. If I'm in C++ land, I'm a total fan of running a linter now. Because it takes more time, but it saves you so much on the back end. And if you do have somebody who's tracking your schedule, you can usually get a more predictable schedule cadence as well. It's like, okay, this took longer, but I can tell you when I'm actually going to be done, and it's going to be correct with a greater certainty.
Well, I'm a big fan of putting the linter as part of the language.
Oh, yeah. Yeah.
It's not a separate tool.
Did I mention I've been using Rust lately?
Yeah, when you put the Rust linter up on the slide in the beginning, I thought, what the hell is that for? I mean, Rust is supposed to be kind of like a super linter. Why does it need an extra linter?
Yeah.
But you did make that point clear later on, so thank you for that.
Yeah. The one thing that really surprises me, and I've been through enough cycles now with Rust, I'm just starting to see this. When they introduce new features, like a better way of doing something, they usually introduce a lint along with it. And so you'll go back and you'll recompile your own old code, and all of a sudden, it'll fail to pass the linter, and it's like, oh, have you tried this? And it's like, what's that? I've never seen that before. Oh, it was in the compiler they released 2 weeks ago. Okay, I'll fix it. Actually, I take that back. The other thing they do have in there, and I have not used it because I'm not 100% sure I trust it yet, although one of my colleagues uses it all the time. There's another command to actually automatically implement those updates. So when the linter spits up on something, it will give you the a sample replacement code, sample blocker replacement code for that. There's actually an option you can do to just say, go ahead and just do it for me. And
I don't know, that makes me nervous.
Yeah, I'm with you on that one. Let me put it this way. My colleague that enjoys that is much younger than I am. But it's, in all honesty, I don't think there's a single case where when I fix something like that, I didn't just take the suggestion and put it in manually. So, to the credit of the youngin', they're probably being more efficient than I am, but I still kind of want to understand what I'm changing in my code.
Well, what I'd like it to do is automatically put the right printf format specifier in for me. I always get those wrong.
And you know what? I do the same thing in Rust. It's got its own little, printf language thingy in there, and it's just as obtuse as C and C++ one.
That's why D's version of printf, you just go %s, and it figures out what to do for it.
Yeah.
You're not using standard format?
No. Oh,
Not
in D?
yet.
Yeah, there is a standard format in D, but in the yeah, there's a formatted write function, and you just go %s, 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 and it looks at the types and puts in the right.
Yeah.
Does the obvious thing with it.
I don't know. I don't remember if the C++ linters do it or not, but the
They do. They don't insert it, but they do complain about the format mismatch.
okay, that's where I was going to go. The Rust linter, if you've got the wrong number of arguments versus argument specifiers or types, it will complain about that. I don't remember if the C++ one does or not.
Yeah, the D actually recognizes a C printf format. And a couple of years ago, I thought, why am I still struggling with this? And I wrote something in the compiler that will compare the argument types against the format specifiers, and it will tell you which one to use. And
yep,
it's so much better.
Yeah, that's one of my common mistakes in C++ land is, specify 4 parameters and give it 3.
Oh yeah.
And then the last one just comes out, whatever garbage happened to be on the stack. And it's like, where did that come from? And what? Oh, okay, I know what I did.
For me is, what's the format specifier for a size T? I can never remember. And
Yep.
I switch memory models and it fails compilation. Tired of that.
Yeah.
Isn't it %ZD or something like that, or %Z? I forgot.
I have to go look them up every time.
You see, you have the same problem with Z. Yeah, okay.
%I, %S, %D.
You're as bad as me,
I think
Lloyd.
that's about all I remember off the top of my head. Yeah, if I need something else, I have to go look it up. And then, of course, we've got code that's written in C as well. And there's no operating system. It's bare metal C. And it's for flight code, so it's been stripped. So one of the things you do when you write, anything for flight is you strip the standard library out and strip it to bare metal, so you have basically less of a surface to test. It's not necessarily about memory consumption per se. It's anything that's in your code has to be tested and qualified. So you get rid of all of that. And the group I'm working with went ahead and re-implemented printf as a very stripped down, minimal version with a completely different style.
Oh.
And I see why they did it, because it made it much, much simpler. But much simpler and much easier to verify. But it drove me nuts for the first couple of weeks. It was like I kept writing, the standard version, and compiler would spit up and say, no, this isn't there. Or sometimes you get to the link stage, depending on what I wrote, and it's like, what do you mean printf? There's no such thing as printf. What do you mean there's no such thing as printf? Oh yeah, they took it out.
Yeah, I implemented it 40 years ago and never want to look at the implementation again. It's just a rat's nest.
Yep.
Got it debugged once. Okay, I'm done with it, and don't ever change it.
Okay, other thoughts, questions, comments? Panics. Okay, I'll note it one more time. The August meeting of this year is going to be member lightning rounds. So if you've got a 5 to 20 minute little mini presentation you'd like to give, we'll be doing that in August. You can also use that as time to practice for CPPCon. So we've got a relatively friendly audience here that won't kill you. Hey, Chris, speaking of CPPCon, do you have any updates on that?
Yep, just put it in the comment field. Call for submissions opened late last night.
Ah, cool. Okay.
You got about 6-7 weeks to get that in.
You want to do a talk at CPPCon? How to do a submission?
Yeah, it's a good idea to always practice it first in front of an audience that won't tar and feather you too bad. But or maybe they will, and you'll learn and you'll give it better. So.
Yep. Okay. Well, I guess with that, we will wrap. I was looking for speakers. I actually do have one for next month. So we're good to go there. July may still be open. I'm not completely sure on that yet. I got to pin that down. And then after that, I'm starting to book for next year. So if anybody wants to give a talk, let me know. Okay, I guess with that, we can go ahead and stop the recording. Thanks, Robin, for handling the recording for us, by the way.
Thank you, Lloyd, and thank you, Robin.
All right, I stop recording.
Yeah.